In our last classes, we have studied what is actually why we need programming language. Then we have studied that how actually the layered view work. That means whenever you write a program in the programming language and how it gets connected to the bare machine at the lower level, that is the hardware level. And then we have seen that why we actually studying this course, what we are trying to learn from this course. And then we have seen what are the different domains of programming language or different areas of programming language. Then we've studied the 7 evaluation criteria, the main evaluation criteria of a programming language, that is readability, writability, reliability, cost. Then we had this 3 as well, where we got generality, portability, and well-definedness. Where is it? Oh, yeah, so this 3 as well. Okay. Now, one was left, that was reliability. So to understand the reliability of a program, we actually need to understand these 3 criteria. First of all, type checking. Second is exception handling, and third is aliasing. Now, all of you are already familiar with exception handling. If you have done the C++ course or the Java course or the C# course, okay, what we do in those programming languages, okay, normally what happens that sometimes whenever you write a program and user gives input that is not supported, okay, by your program, the program crashes instantly. Okay, so we don't mind that. Okay, so we know that if the user gives a random input that is not supported, the program will crash. But what happens that in C++ and Java, we came up with a better approach to handle these scenarios. Instead of the program crashing, okay, we have made sure the program can handle this type of inputs. So what we do in the exception handling, okay, we take corrective measures, okay, that if you face this type of issues, if you face this type of problem, okay, take this type of steps or give the user this type of notification. For example, if you suddenly have a random input that is not supported, instead of crashing the program will say this is a random input or this input is not supported, please try again. If you don't have internet connections, okay, what will happen, that normally the program crashes, but in this case the program will not crash. Okay, it will just say that this internet was not found. Okay, so these will like understand that what actually is wrong with the input so that he does not make the same mistake next time, or what is the runtime error so he can take corrective measures. Okay, so this is the easier one, that is exception handling. So I have one example here. So first of all, let's assume that whenever you are trying to connect to a server, okay, and so whenever you're trying to connect to the server, what can happen, then the server cannot for some reason send you the data. Just now think about right now what happening. You are in the all of us are in the Zoom platform. So whenever I am speaking or I'm showing you a slide, the information is going to a server, and from that server you all of you actually downloading that video or downloading the information. So basically what I can say that from my computer is going to a server, and from the server is going to all of your computer. Okay, so now if suddenly the server actually don't work, okay, for some reason, so what should happen? So the exception handling says that okay, in that case you should have a backup server. So what the program will do, it will first try to connect to the server. If it's unable to connect to the server, it will call the backup server. So the program will make the decisions on its own. So using the exception handling, we actually make sure that the program can take its own decision in case of exceptional cases, okay, like wrong input, or then if he can't find the server, okay, or if for some reason the program is not or the server is not responding, it takes the decision on its own. Okay, and if it can't take the decision, it actually show you that this is type of the problem I am facing. Okay, so this is what we call exception handling, and this is a part of reliability. So if your programming language is reliable, that means you can depend on the programming language to make some of the decisions for you, okay, instead of just instantly crashing, okay, out of nowhere. Okay, we call it a reliable programming language. Okay, so this is the simplest example of exception handling. So we always have a class. Let's assume the name of the class is connect. So normally what we do, like if the server is up, okay, we write the code to connect to the server. If the server is not up or not responding, we connect code to the backup server. Now, the question is that there's a structure to the exception handling that is called try and catch block. Okay, so if you are not familiar with the exception handling, I will ask you to search that how the try and catch block work. But to give you a simple idea, okay, so here, as you can see in the green part, okay, what we do, so we have in the try block, we actually write the code that can actually have exception. That means that can lead to an error or that can actually crash. For example, if you're trying to connect to the server, okay, the code to the connect to the server will be written here. Or if you're trying to take an input that can have multiple types of input, so the input will go here in the green part. So whichever part of the code might have error, okay, or might lead to some error, that will be in the try block. Okay, and then whenever there's a error, okay, what will happen? It will go to the catch block. In the catch block, you will write that if this type of error happens, do this. Okay, so this is called try catch, and there's a small notation here that is we call throw. Okay, so throw is that whenever there's an exception occurs in the try block, we use it to throw into the catch block. To put it in simple terms, what is exception handling? Whenever there are some unknown scenarios, unknown inputs, or unknown runtime errors, in that case, normally the program crashes. So so that the program don't crash, we use this exception handling, that is try and catch block. Okay, what we do, we actually think of all the scenarios that can happen. So if you're trying to take an input, okay, and if you think that, okay, so user can give invalid input, you are trying to take a number, okay, but the user can input ABC. So that is an exception. You are trying to take an input a number, the user can give plus, minus, or other symbols, okay, in multiplication or hyphen. So that is also an exception. So you will say that enter a number. Every time the program and the user enters ABC, or the user enters as plus, minus, or multiplication or hyphen, that means other sign, you will reply the user that you have to enter a number. In this way, the user will understand, okay, so I'm making a mistake here, instead of the program crashing. Another type of scenario is that you are trying to connect to the server, you are trying to have an internet connection where the server is not responding in the time. Instead of just keep trying to connect to the server, you will try to connect to the backup server as well. So you are making all these small decisions that are actually making the user's life more easier. Okay, so that's why we call it reliability. Now, so this was the and the last two is type checking. What does the type checking means? Okay, so whenever you run a program, there are two type of situations we can face. One is the runtime errors, okay, or compile time. So the difference is that it doesn't matter which type of error or type checking you are doing. Okay, so what we will do, you will test the type errors ideally on the compile time, not the runtime. Okay, so that's a good practice. So first of all, what happens if you check in the compile time, the errors actually get caught first. Now, if you're not familiar with the difference between runtime and compile time, what is a runtime? Runtime means whenever you are actually executing the program. And compile time means when you are testing the program. That means you are first running and compiler is going through all of the lines to check whether there is an error or not. So what we try to do, okay, we try to find errors in the compile time, because you can correct it. But when the program is running, okay, you cannot actually change the program because the program is already running. So what we do in the runtime, we detect the earlier errors, okay, and the less expensive it is to make the required repairs. So the earlier you check the types, you check the errors, the less mistakes the program, or the less expensive it is to make the required repairs. So it is actually difficult to understand in case of small projects, okay, but if you think about a big project, okay, in that case it will make more sense. So whenever you develop a big project, what happens that there are a lot of components to it, and whenever you make a small error, okay, and if you don't correct the error, the other engineer will work on top of your error. And then if after the whole project is done, and if then someone finds the error, all other engineers that are connected to your component, they all have to change their code sometimes. Okay, so that's why we actually try to find the code before it's going to the runtime. So that's one thing. And finally, the aliasing. Aliasing is very simple. So whenever we have like two or more distinct referencing methods for the same memory location, okay, that is called aliasing. That means think about like this, that you have a variable. Okay, so what you're doing for that, sorry, you have a memory location. Okay, and for that memory location, you are using multiple variables. So like think about the one address like IUBAT. So instead of saying directly IUBAT, one is saying that this is the university of person A, this is the university of person B, this is the university of person C. All of you are actually referencing to the same place. Okay, but instead of saying the address, what you are doing, you are giving a different name. So whenever you actually create a big program, okay, with a database and other modules, what we tend to do, okay, so every time a developer opens the code for his own module, he actually creates own variable name. Okay, all of them are point to the same memory location, but in different module, you are using different names. Okay, so what we do, sometimes even we set 2 pointers to the same variable. That is also unacceptable. To put it short, whenever you are using a variable, try to make sure, or whenever you're using a memory location, try to make sure that you use one single name for it, for the referencing of it. And this is called aliasing. Okay, so now the aliasing is now widely accepted. Okay, this is a dangerous feature for the programming language, and you will not hear the word dangerous for a lot of the terms. Okay, they will see there are errors, there are bugs, but whenever they say dangerous, that means that it sometimes leads to some serious programming design problems. Okay, especially if you have done system analysis and design, you will understand why the problem occurs. But for now, to understand it simply, aliasing is a problem when you have two or more referencing for the same memory location. So that's all about our reliability. Now, finally, after understanding all this, how we actually can evaluate a programming language. Let's just take C. Okay, so let's assume that you are trying to learn a programming language. Okay, so then as a developer, okay, I have decided, okay, so I need a language that is simple. So out of all the programming language, which one is simple to read and write? So I can choose, okay, C is the very simple to read and write. Okay, then if there's another feature that, okay, I want to learn a programming language that is portable, then I can say, yes, Java is the one for that. Then if I want to learn a programming language for that, abstraction is important. So for that, I have two programming languages, C++ and Java, that provides the abstraction. Then I have to choose a programming language that is also the performance is important. In that case, we have C programming language. Then we also want to learn a programming language that is like, let's say we want to artificial intelligence. In that case, let's say we have a Prolog, okay, for artificial intelligence, we have Perl for text processing. So every time you're trying to make a decision, okay, now you know the parameters. And when you ask yourself these questions, okay, there are many other questions you can ask depending on which type of programming language you are working with. Okay, so what you do, okay, you try to repeat those, okay, these criteria. So one by one, you first ask yourself that, okay, so what you actually need. So let's say you are a software engineer at one of the top companies. Okay, now you have to make a decision that we will develop this project. Okay, that project needs to be simple, there needs to be portable, there needs to be abstraction. Okay, performance is also important. Now you have to make a decision that which programming language or which platform you will choose. And from there, okay, you will actually have to ask yourself these questions, and then eventually you will get the idea. And let me tell you one thing, that it doesn't matter which decision you take, you will always have some pros and cons. For example, if you take Java programming language, okay, you will get many advantages such as portability, abstraction, okay, but the performance will not be as good as C. Okay, so it doesn't matter which language you choose, there are some pros and there are some cons. Okay, it depends on your project. So it's actually difficult right now to get the idea, because I don't think you have fully developed any projects. Okay, but when you do, you will actually understand this much more. Okay, so let's go back a little bit. I have a question about this. Where is it? Aliasing, right? So what is the concept of aliasing? Let me repeat again for those who didn't understand. Sometimes what we do, especially in a large program, okay, so let's say you are using a pointer to a memory location that is A. Okay, now whenever you have used that A in two function. Okay, so let me draw a picture. I think that will be easier. So let's say you are using a program. Okay, the program, this is the program, and in that program you are actually have this is the function that is integer sum, let's say simple names, and this is integer main. Okay, so what you're doing, okay, in the main function you're calling the sum function with two variables A, B. Now what aliasing means, that let's say that you are using a variable, okay, that is integer age. Okay, so let's say this is the pointer. Now this pointer, let's assume that this pointer is pointing to a memory location. So whenever you write age, this is pointing to a memory location in our computer. Let's say this is the memory location of age. Okay, so whenever you created this memory location was created. So this is where the data will be stored. Now in this function, okay, you are saying it age. Okay, then you are writing that sum equals to, okay, I should remove this. Where is the eraser? Yeah, got it. Oh shit. Oops. Okay, it's hard to remove only this. Okay, let's try to cut it down. So let's say we're calling the function with the variable age, okay, and another variable n. So what they're saying, okay, then in this function we'll process age. Let's say age equal to age into 2. So a simple program, we are taking a pointer. Let's say we're assigning values, then we're calling a function. Okay, and then in this function, okay, what we're doing, we're just multiplying the value by 2. Now what happens, instead of calling age this, what you do, okay, you think, okay, this is a new function. Let's set a new name. Okay, let's say you have said new variable equals to new into 2. Now your program will work, okay, because this value will be passed down to this function and this function will get the new. But what they're saying, that whenever you are doing this, try to use age here as well instead of using a new name. So that's the one thing. Okay, so because both of them are doing the change here. Okay, every time you write this, the change will be done here. So that is the first thing of the referencing. So whenever you have a variable, the multiple pointers or variables that is pointing to the same memory location, try to use a same name. Okay, that will be easier for the developer to understand, and it will help you to make not make any mistakes. So that is the first thing. And secondly, what we're saying, that whenever there can be another type of aliasing that most programming languages allow. Okay, for example, two pointers can be set to point to the same variable. So pointer A, pointer B, both are actually pointing to the variable A. So how does that look? So here, there's another example. So let's say integer A, integer B. So these are two variables. Now I am declaring two pointer P and then pointer Q. Those of you don't remember what is a pointer, pointer is also a variable that stores the memory location of a variable. So now what you're doing, so you are writing P equals to and A. Okay, so that's how we use pointers. And then again, for some other reason, okay, you are also storing P equals to and A. So you see these two pointers, all of them are storing the name of the same variable. So that is the second case that they are actually saying that don't do that. Okay. Now, initially it's difficult to understand that what's the problem. This is my program, I will write it anyway. But they are saying, no, this is actually dangerous. If you're developing a big project with a lot of modules, this aliasing is a dangerous feature in a programming language. So that's it. Now, I hope that answers your questions. So what we have, yeah. So the next is that what is the trade-offs? So as I was saying, that sometimes it's actually difficult to make a decision. Okay, because doesn't matter which decision you take. Okay, you have to trade some of the goods with some of the bads. Just think about it, that you are trying to buy computer. So you have two options. You can either go for desktop or you can go for laptop, for example. Now, if you go for the desktop, the advantage is it can take a lot of it's cost less. It will cost less, okay, the desktop compared to the laptop. And another advantage is the desktop will eventually last long. That's all of us know. So desktop versus laptop. Okay. So let's see what are the advantage, disadvantages. So for the desktop, it's cost less. For the same specifications, it cost more. Okay. For the desktop, it will last longer for sure. And the parts, if some part does not work, you can easily replace it with, but it will, it doesn't last that long. Okay. Okay. So I should have written here. Just a minute. Then what is then for the desktop? Okay, is not portable. If you're in a business that you need to give a lot of presentations, in that case, you need a device that is portable. In that case, laptop is portable. Okay, and convenient to use. So this way, now you have to make a decision. So which one is need? That is called trade-off. That means either you have to choose between one of these features. Okay, same way, like if you go to buy let's say you're going to the market to buy a dress, the dress you like might be more expensive. Okay, we don't have that much money, but it might not be last that much long. So in that case, you also have to make a decision. So this type of decisions, we call them trade-off. So here, there's first trade-off, that sometimes the reliability and cost of execution. For example, Java programming language, these two are conflicting criteria. Why? Because Java, which is a very demands reference, Java is a programming language, is very popular, okay, and it demands reference to all the elements of an array to ensure that there's a reliability of the program. But whenever you try to ensure all those reliability issues like exception handling, aliasing, type checking, what happens? The cost of execution increases. How? So the more reliable your code is, the more line of code you have to write. And the more line of code you write, the more time it will take. So in the Java programming language, what happens? The more reliable the code is, the cost of execution also increases. So you're thinking, okay, I am going to use Java. So you have decided that you are going to use Java. So in Java, either you have to choose reliability or cost of execution. So if you want to make your program reliable, in that case, the cost of execution will be high. If you want to make the cost of execution low, in that case, you will have to make it less reliable. So I hope that you understand the point. It's saying that for the same programming language, sometimes we face this type of problem. That if I want to make my program more reliable, in that case, I have to write more lines of code. In that case, the cost will be also high. But if I want to if I want to use less cost, okay, then my program will be less reliable. So you have to now think that which one you should go for in the same Java. Now we are not choosing between Java and C. We have decided that we will go with Java, and then we are facing this problem. Then another example, readability versus writability. Okay, so write means it will be easier to write. So think about Python, okay? It's easier to write, okay? But to understand the code that was written is a little bit difficult because there are a lot of abstraction to it. So in C programming language, let me show you an example. Let's say that we are not using any built-in functions. Okay, in that case, in the C programming language, whenever you try to sort an array, you have to write the details of the sorting algorithms. Now, it will be easier for you to understand that. You'll understand, okay, so this is the sort function, and this is how we do the sort. So the program is more readable. It's easier to understand what's happening everywhere. But it's not good for the writability because you have to write all the sort functions. In the corresponding to that, what you can do, okay, you can just call a built-in sort function. Okay, so just you will pass the array in the built-in function. Okay, it will automatically sort. You have no idea what's happening. You just know that your program is getting sorted. So you just have to write one line of code. Okay, but your life will be easier, but it will be difficult to understand that how the program is getting sorted. Okay, you might have to use some other print techniques or some debugging techniques to understand that is there any error or not. So the point is, in C programming language, both cases, okay, if you're using a built-in function, okay, in that case it becomes easier to write. Okay, or think about Python. If you are using built-in sorting algorithm, it becomes easier to sort it. You just have to write one line of code and that's it. But whenever you're trying to understand how the sort is being happened, it will not be clear. But if you write in details, okay, it will be difficult to write, but every time you look at the code, it will be easier for you to understand that, okay, so this is how the sort is getting done. So you have to make, you have to do the trade-offs like this. Okay, then you have the writability and reliability. So how this is exactly related to the first one. So for example, in C++, pointers are very powerful and flexible. Okay, but they are actually not reliable. Okay, and sometimes we don't even use pointers in Java. So some of the features we also face this type of problem, that they are supported by one programming language or not supported by another programming language. So the point is, the first thing is you have to decide which programming language you want to choose, okay, depending on all this evaluation criteria. And after that, when you choose one programming language, you might also face this type of trade-off problems, that in that programming language, out of all the criteria, you can only go for one or another. That we call the conflicting criteria or trade-offs. So then you have to make a decision on that as well. So that's all about the evaluation criteria. Okay. Now, for the next part, we'll just talk about some basic topics of compiler and the language design so that it helps us to understand the next chapters. Okay. So let us start with the first one, computer architecture. I have understanding that all of you have done the computer architecture course. So all of you already know what is an architecture. To put it in a simple, that computer architecture provides you with the overall view of how computer communicates with the user, with the CPU, and with the other devices, how the data actually flows from one device to one component to another computer, how the data gets processed. Okay, all of the study of all this is called computer architecture. Okay, now the languages developed around the prevalent architecture. So one of the most prevalent architecture is von Neumann architecture. Okay, we'll talk about that as well. Now, I think we have discussed this in the first class. Let me check again instead. Yeah, so this was the von Neumann architecture. So most of the programming languages that we have here are developed around this architecture so that it can handle this type of operations, that you'll have a memory, you'll have a control unit, that is CPU, and then we'll have devices. So the programming languages are built in a way, they get stored into the memory one by one, they get fetched by the arithmetic logic unit for the execution. So this is one of the most common architecture. Then what you have, okay. Next is programming methodologies. Now, you know that as a software engineer, you will see in future that every year and then it will develop new software development methodologies that you should do your program in this way. Okay, so right now the object-oriented features are very common. Okay, so it's the, I can say, this most popular one. Okay, but still the community, okay, the researcher, they're constantly trying to develop new programming methodologies to make the overall operations more easier, or to face the challenges of the upcoming technologies. So the programming languages are actually evolving over time. They can do more now. Okay, they can do it in a faster time. Doing the simple task is not enough. Okay, so the extensions are given every day. Now the question is that if you're a programmer and you only know one programming language, how do you actually evolve over time? The answer is you don't have to. If you start from the basic, okay, it will eventually, you will understand the rest of it. Okay, that's how the programs are evolved. So it doesn't come from nothing. Okay, the C++ came from C, the Java came from C++, and so on. So these programming languages are connected to each other. Now, wait, let me restart the meeting.